Hey friends, hi, good evening everyone, and welcome to 360digiTMG channel, friends. Hope everybody is fit and fine, doing wonderfully well and healthy. This is a session that I wanted to conduct from a long time now, and at last time has come, and let's discuss about primarily the steps that are to be considered after machine learning model is deployed, right? So that's the focus for today's session. So we basically know the entire machine learning workflow, isn't it? We are data scientists, we are machine learning experts, we are machine learning engineers or experts, and we are familiar with building machine learning models, isn't it? And right, we basically follow, or we used to follow, CRISP-DM methodology. You will have to focus here. CRISP-DM is what I'm talking about, and this was the standard practice that used to be followed in the industry. But a lot of things changed as and how the machine learning world, as the data science world itself has evolved. For me, literally, it was like personally, pre-COVID and post-COVID right arena. So the pre-COVID times were CRISP-DM things, whereas after COVID, a lot of research happened in COVID times, right? So after COVID, we had a lot of things upgraded in this particular pipeline, or in this particular process methodology that we used to follow. Of course, it contains 6 phases: business understanding, data understanding, then we clean the data. After that, we build the machine learning models, we tune it, and then we will evaluate the best model and use that best model to deployment. Now, recently, I have made a post in my Telegram as well, sorry, my LinkedIn as well. I was trying to explain the differences between CRISP-DM methodology and CRISP-MLQ methodology with respect to an architectural diagram. Now, let me tell you, this is my favorite example again, because it includes my favorite phone. If you remember, there was this Nokia phone which used to be working on Symbian, right? What is that? Old mobile, which had the digital buttons, and right, there were no digital screen. It was all analog screen, and buttons were there. I think 1110 or something. Now that was a very good arena, and right, at that times the mobile was like of good quality, isn't it? But there was a challenge, friends, in those days. Let me try and explain you that. Let's say I go to the store and I purchase a phone. Okay. All right. I'm talking about 20 years or 30 years back, let's say. So when we talk about this 20 to 30 years back, when this phone was available, when you purchased, or when I purchased this particular phone, I only got the product. What that does mean, or what does that mean is, I don't have a support for upgrade. Can you upgrade these phones? No, we couldn't. And that is the reason why these phones, though were so popular, could not sustain in the market, because they were not designed to tune themselves, upgrade themselves. So the entire software, including the operating system and various other applications, were hard-coded onto this piece, one hardware. So there is no upgradation option. This was the challenge. So same thing used to happen in this particular methodology as well, CRISP-DM methodology as well. That is, you would be given data. Right? This is what we do, isn't it? We get historical data. As soon as we get this historical data, forget about everything else, we jump. We jump onto the data. Isn't it? Forget about business problem, forget about whether the data is relevant or not. We are least bothered about all those things. We just directly jump on the data like we have not eaten for 1 week, isn't it? I'm pretty sure a lot of people are smiling now. So when you get this historical data, we try to work only on this data. That's all. We don't map this data to the business requirements. This is something that a lot of people right, do. This is completely wrong, but this is what is being done. Because when business comes with a problem, it is impacting their day-to-day activities, and it is going to impact their day-to-day activities in future as well. The overall business is getting impacted, not only for that movement. This is only a sample data or old data that we get. Now we need to use this for reference purpose, so that we can understand the problem and we can also try and figure out a solution. So we use this historical data for reference purpose. This is nothing but trying to identify some hidden pattern which can explain details about business. This is what we should be doing. Instead, in CRISP-DM, we only try to build a solution for that particular given data set. That's all. Right? So this is like one of solution that we build on the historical data. This is a typical pipeline that we follow. We get the data, irrespective of what is the source. We ingest the data, we collect the data into Python. Then we start our EDA, cleaning, organizing, transformations, right? All these things is what we perform. Now, once the data is ready, cleaned and organized, we go for model building. Depending on what is your target, you would choose your appropriate method, machine learning model, whether regression problem or classification problem. So model is chosen. Once the model is chosen, you will start training it. So you decided to build a naive-based model or KNN method or decision tree model, whatever it is. Right? So you choose one algorithm and you start training the model using the historical data that we have got here. Right? We are cleaning it and we are using that for training purpose. Once the base model is built, we try to evaluate the model. We test, we capture the metrics, and we basically see whether the results of this particular model are good or not. Right? And in order to do this model evaluation, this historical data that we are getting here is partitioned. We get train and test. We get train and test data sets. This is basically done on trained data set, and this is done on test data set, right? Train and test. Now, once the model is evaluated, we probably will not satisfy with the results. So we do tuning. We change parameters, we alter some of the data points, we do the transformations and all that, and we build the model, right? Hyperparameter tuning. Isn't it? So we keep doing this hyperparameter tuning. Now, once this is done, by comparing multiple models, we will choose the best model based on the metrics that we are capturing here. And this model will be served. So we will save the model either in pickle file or joblib file or different formats of that. Most popularly used for statistical models is your pickle file or joblib. We deploy it. This is a typical machine learning workflow. Correct? Now, there are certain challenges that we will have to understand in this flow also. Let us try and understand that. Now, when you say deployment, to start with, you need to look into certain questions. Now, deployment, of course, is probably you say, hey, I'm a pure data scientist. I'm not a coder. I'm not a programmer. So deployment and all that, don't ask me. I have given you the file, saved model, right? The best model. But as a developer, as a machine learning expert, as a data scientist, you also want to know whether the solution that you're developed for your customer is working properly or not. Whether your customer is in the first place able to use it appropriately or not, isn't it? So when we talk about deployment, you need to look into some of these questions. This is only a sample set of questions. We're not bringing in all the questions here. Some of the sample questions, I'm sure. Customer's environment, right? What are the various dependencies? New data comes in. So when new data comes in, how does your model perform? This is very, very important, and we will focus on this. All right? Now, you also have to see whether the customer is experiencing the same level of performance that you experience when you're when you build your model, when you train your model. Right? So this is also something that we need to check. So on and so forth. There are many bunch of questions that we will look at. This should trigger some doubts in your heads, right? So fine, I build the model, I save the model, best model, but how am I going to serve that to my customers? If they're not able to use it, there is no point, isn't it? So there is a very big right science behind this entire discussion of deployment. Of course, that is not the complete scope here that we will be discussing, but this is a chart that you will have to look at. And this chart is designed by Google way back in 2014, right? Very, very old presentation, slide. This basically talks about the emphasis that we have to give for rest of the technical requirements, rest of all the requirements, right? Not just the machine learning code. The size should basically give you the indication on how important the other pointers are when you're trying to deploy a machine learning. All right, so these questions had to be addressed. Right now, whenever we talk about the machine learning models, then this is basically something that we will have to look at. But what we do is we completely focus on the machine learning code. That's exactly what I was saying, right? We basically start doing the coding. Once the data is available, okay, forget about everything else, build the model. You would get a .py file or .ipynb file, and you do some rigmaroles and say, hey, my accuracy is 95% plus. So this is the best model. Let's start using it. Okay? This is what we do. But scaling and deployment struggles are there. As we discussed, right, this chart. Deployment, yes, I've already talked about software, hardware dependencies, and all. A lot of these things come into the picture. The another point was scaling. So when you are developing your model, you probably are developing it on a historical data, which is a limited small size data, and you're using a local machine. And you are a single user. So your local hardware is good enough to deal with this kind of a load. But when your model goes into the client environment, customer's environment, we don't know how many end users will be using it. You may have just one user, or you may have 100,000 or more users. Do we know that? We don't. So you need to also decide on how your model is going to scale to this requirements. It has to support those many requests, right? If everybody starts using it, probably will not get good traction, isn't it? So you'll have to balance. And when I said 100,000 users or 1,000 users, or whatever that number is, you probably will try to plan your resources in such a way that you say that, okay, let us have the resources planned to support this kind of a load. But if that is the case, and what if you have only 100 users? You plan for these many users, but you have only 100 users. So that means the cost that you have incurred, that you have invested in getting these resources is wasted, right? So you need to look at the strategies on scaling up and scaling down, both the cases. Okay, next. The another important point is the continuous learning. As I mentioned, the ML model that you are developing is now a software application. It's just an application like your mobile application that you have, isn't it? It's an application for the customer. And customer would expect that application to work, right? For forever. It's like unless they don't want it, they should be able to use it, isn't it? Now, when you talk about this application or your machine learning model, it is nothing but a mathematical equation which is representing the relationship, right, between your dependent and independent variables. But as the business moves, right, what happens? Your business evolves. Your business transforms, right? It does make shifts. So when your business is altered or changing, your data will also accordingly change. This is basically called as data drift. Okay, data is changing. Okay, that is one very important point. Let me also put it here. Data is changing. We call this as data drift. For example, before COVID, right? If I talk about real estate, this is a very, I'll take this simple example. Let's not get into other examples. Real estate. Before COVID, right? I come from Hyderabad. A lot of people, let's say till 2022, were investing in independent villas, independent houses. But after COVID, 2022 onwards, this is till 2021, from here, people started looking into high-rise buildings, high-rise gated community buildings. So if you look into the data set, right, if you talk about cost, the property costing has get impacted, isn't it? I'm not just looking into the trend of the cost. I'm looking at the other features in the data set which are getting transformed. For example, before COVID, you would have independent houses, right? If one of the columns says type of the property, it probably would say independent. Now we will say gated communities or high-rise gated communities, right? So different categories. So till 2022, your proportion for independent houses compared to high-rise houses, independent houses would have been very high. But after COVID, the picture is the other way around. High-rise buildings are more. So the cost, because ultimately it's a relation between Y and input variables, right? So your Y will not have same effect from this X after COVID. It changes, right? Now, if I try to use this model, which I built before COVID, then I would get a biased results because in actual, the conditions have changed, right? So this is called as data drift. There are various examples that you can look at, all right? Then this data will impact the model also, isn't it? Because if your data changes, your model performance also changes. We should be able to capture this. So we need to ensure that the model that we are using is constantly maintained and updated with respect to the new data that is coming in. This is called as continuous learning or continuous training, CT or CL. This is basically nothing but your Android operating system based phones. Android based mobile phones. Because as your operating system gets updated, your mobile phones can also get those updated softwares. That means your mobile also becomes latest. Unlike your Nokia example that I've given, right? So to implement this, we need to look at the continuous training aspect. This is where we have crisp MLQ methodology coming into the picture, wherein this is the additional step that has been introduced. Monitoring and maintenance. This is still a research area. A lot of people are contributing in researching in this area and bringing up new tools, right? New solutions, new architectural designs. So as and how experiments reveal new things, they're trying to bring in those things. Now, we will be looking into one tool which allows us to monitor the most important data drift in our model. All right. So monitoring and maintenance, that is basically what we will have to focus on. So when we talk about deployment, deployment talks about providing the end users some end point, or you can say access to your machine learning model. We are not talking about code. We are talking about end users experience using this particular machine learning model. So end user expects a UI, user interface. Streamlit is basically a platform, or you can say it's a framework, which has a lot of inbuilt widgets, UI features, components, which allows data scientists or machine learning engineers to quickly design the UI. Not just that, right? Not just that UI, but Streamlit framework also allows you cloud platform wherein you can host all your code for deployment. Over internet, you can give access to your application to the end customers. So whenever we talk about deployment, remember there are two things. One is the UI component. The other one is the server, which is hosting. Okay, we call it as hosting server, which basically is storing, or which is basically having all the code that is required for your machine learning model to run. So you have software, you have a hardware. Combination of these two is going to be your deployment. So Streamlit is like a wrapper, which gives us a UI to the end customer, and which is basically embedding the ML code, or saved model, I should say. Right? It packages that saved model and gives the UI. So this is a Streamlit application, friends. And when we talk about Streamlit, it's a very simple right tools, and there are some of the examples here. All you do is use these widgets, and it basically allows you to get the UIs. Right? ST, it's basically ST is nothing but Streamlit in short. So Streamlit is a library, Python library. You install Streamlit and then say import Streamlit as ST, and then these are all the functions that you have. All right. Now, coming to the important aspect of your model deployment and post-model deployment activities. So as part of this session, we will be looking into how do we capture the data drift concept. All right. So this is the UI that we will get. You can change the colors, the look and feel, and all those things. Right? If you experiment or if you explore. Say, for example, the libraries, the existing Streamlit widgets. If you go to the official documentation, there is a lot of readily available widgets that you can use to change the look and feel. All right. Now, let us move on to talk about evidently. Okay, this is because the sixth phase of CRISP MLQ methodology, which is monitoring and maintenance, is something that we will have to focus heavily now. The model which is deployed, right, it has to be constantly monitored. Why? Because as time goes by, the model degrades its performance. It degrades. This could be because of the distribution changes or various other factors that come in. So we will have to closely watch the performance of the model. This is called as model monitoring. This is also to ensure that there is consistency. What you build and what your customer is experiencing should not be different. Right? And we also need to ensure that continuous training strategies have to be implemented. And from that perspective, also continuous monitoring is required to ensure that we capture these changes. Model drift or concept drift. All right. Now, there are many tools. There's no doubt about it. There are many tools that are used in the market right now. These are some of the examples that I am putting here. We will be talking about Evidently first, which is again a Python library. It's very simple to use. And a very neat documentation is also available, which can be used for capturing the or doing the monitoring with respect to your data drift capture and model drift capture. So whenever we get a new version of the data should also, the new version of the data should also contain similar distribution, right, with respect to your historical data. Because we're talking about patterns in the data set, right? Now, when you're looking into the historical data and detecting some pattern, right, you're using this pattern to solve business problem. You come to conclusions. But if your new data contains a different pattern, then the solutions that you're developing based on this historical data information will not work in the business case. Because in the new data, the distribution has changed, isn't it? So we need to track this. That's called as drift. And this becomes the primary reason why your model degrades. All right. Now, to capture the drift in the data, there are various things that we can use. Predominantly, it is a simple statistical tests like hypothesis tests that are used. Some of the examples of those tests are given here. Kolmogorov, Smirnov, chi-square, Weierstrass, Jensen-Shannon, right, so on and so forth. So these hypothesis tests are basically, if I have to explain that, it is like A/B testing, you can say. Very simple concept. What we're basically doing is we are taking historical data, splitting it into train and test. Now let us assume training data set is our entire historical data. So this is called as referenced data. This is the terminology that is used. This training data is being referred to detect the pattern. Using this information that we are getting from the referred data, we would have to make some decisions on the current data or production data or new data. We are assuming that the test data is new data, assuming. Right? So this is your current data. We call it as current data or production data. Okay, it's not production, so we use current data terminology. Remember the terminologies, okay? Reference data and current data. Say, for example, you have used, let's say, some historical data for, let's say, 1,000 records or 10,000 records better. You use this and build a model. This model is expected to do predictions on new data. So I would have 10,000 more. Right? But again, as I said, the pattern that is available here in 10,000 records may not be the case in this new data. We don't know. So even before predictions are happening, we want to check that the new data that we are getting here contains similar patterns, similar characteristics as of your historical data. Right? So these statistical tests are basically done for checking the distribution of the data. All right? Very simple. So what is the distribution of the data in training data set or reference data set? And what is the distribution of the data in your current data? Current data. All right. So this is basically how we do the comparisons. There are many techniques that will be applied, but yeah, at a high level, this is what we do, compare. So if I had to put it in even simpler methods, simpler terminologies, I will take trained data set, I will do EDA. When I say EDA, I'm basically doing univariate analysis. I'll take each column, I will check what is the mean, what is the median, what is the variance, do we have missing values, do we have outliers, do we have skewness in the data, is the data normally distributed? So all those checks I'm doing and I'm recording them. Next, when I take test data, the assumption or the objective of creating test data set is to ensure that we pass this to the model, get the results and evaluate the results, isn't it? To evaluate the machine learning model. But even before we go to that model value predictions, target value predictions, the data set has to go through certain data preparation steps that we are doing it on training data set, because this and this data set are in the same format. And for a machine learning model, the format will be different. So all those transformation steps that we are doing on training data set should be applied to test data set. So as part of that, we also do EDA, that is univariate analysis on the test data set as well. These records are also, these reports are also recorded. This becomes version 1. This becomes version 2. Reference data, current data. And we compare these reports. Right? That's all. This is the high level understanding. This is exactly what is being done in Evidently AI. It's an open source Python library, guys. You simply do pip install. That's all, just like how we do it for various other tools, right? We simply do pip install. Now, this tool is basically used to compare the model, including the features, the data set, right? Features, the overall data set, the distribution of the data points, right? We will be using it for monitoring the drift that is happening between different versions. We do hypothesis tests to generate those reports, right? And we evaluate it. So it basically does all these things: evaluation, testing, monitoring of your data and models. Now, one thing basically you need to look at is it simply is used for comparison, right? It basically is doing the comparison of data initially, and then finally the model as well. This will ensure that the quality is maintained. And Evidently can give us reports in 3 different forms. Okay, and the reports, we will see, it comes in UI, HTML format, it is in JSON format, it is in dictionary format also, Python dictionary format as well, key and value pairs. It also allows us to do certain tests, right? Pre-tests out there, we will simply run those tests as well, which will of course give the reports. And using these reports, we will also do the monitoring. Excuse me. All right. And it is very simple. It has got the UI. It has come a long way from the time it has been launched. You can integrate Evidently.ai with any of your other platforms, like scheduler platforms or your Streamlit platforms, right? UIs. It's very simple. This Evidently AI is basically capturing the reports, and the UI is used for showcasing those. We can integrate these two. Like very simple processes there. Yeah, but one thing you need to remember is Evidently this works only for structured data till for now. And in unstructured data, it has few use cases to deal with for text data. We cannot do monitoring on image data or audio data, right? Like how we can do it on structured data. It's not possible. It has its limitations. Okay, yeah, that's the point you can see. Evidently currently works with tabular and textual data. Okay, and these are the kind of reports that we get, right? For discrete data, for continuous data, for the distribution of the data, right? The scatter diagrams, all these things can be generated using our evidently.ai. I will show you the code. I'm using a very simple data set. This code I have taken from the LMS class sessions. This is a simple KNN model that I am building. Our focus is to understand how do we capture the drift in the data, right? So we'll be focusing on that, not on the model. And the data that we are using is the breast cancer data. Okay, now let's say assume, right? We have this data set and we are capturing all those libraries, we are loading them. We are basically getting the data from the customer's database. So we will connect based on the credentials that we get. We connect to the database and we run SQL queries from Python to get our data set captured. So I have my data set object. I've loaded this from the database. All right. Now, I will do a bunch of the EDA process. And I'm also dropping unwanted first column, which is ID. Then I'm splitting my data into input and output. The output column is diagnosis column. You can see this is your diagnosis column and this is your input column. You have in total 30 columns plus the gender. All right, cancer data. Now, I will not explain each of this because this is the existing code. We have the data set pre-processing steps that we are performing here. We can do auto EDA, right, and proceed further with the steps. But we also have to do data cleaning. And for that, we are splitting the data into numeric fields, where I'm saying exclude the data types which are object type, right? So when you look into the numeric features, you'll have 30 columns. The sex column is gone. Sex column will come into the categorical features. Now on numeric features, I'm doing imputation. Similarly, on categorical data points, I will be doing the label encoding. So if you look into this first column, this is the gender, right? So I'm splitting that gender into ones and zeros. One hot encoder I'm applying, and I'm of course dropping the first column so that I have a single column where female is 0, male is 1, alphabetical order. This is a pipeline that I'm defining, and using that pipeline, I'm fitting the data model so that I get the transformed data. All right, here I'm fitting, and here I'm doing the transformation. And of course, I'm saving this model as well. So I have clean data here, 31 columns. Sex column is now numeric, and missing values and all those things are addressed. Imputation has also been done. Right here, we are doing imputation. So both the steps are performed, and we have clean data. Now you can see clean data.info. There will be no missing values and all. Okay, again, I'll move on quickly from here. I'll do the scaling so that all the values have same magnitude. And this is basically the result, which shows that the scale is constant for all the columns, 0 and 1. Next, I'm converting my data, output data, the column or the target into an array, and then splitting my data set into 80-20 proportion. This becomes my training data set, and this becomes my test data set. So x underscore train and x underscore test, I have 31 columns. This does not contain the target. Now I built a machine learning model, KNN model I'm building with the base number 3 I'm taking, fitting the data and doing the predictions. So I get the predictions. All right, these are the predicted values. I would check the accuracy of the model. It is 97.8%. And I'm doing the predictions on the test data set also. And I'll also verify how good is this model on the test data set. Okay, so on the test data set, it is basically giving 95.6% compared to 97.8% that we get on training data set. So it is pretty decent, right? It's not too different. Skewness between training accuracy and test accuracy is not that high. But I've done this as a base model. Now I need to do tuning. And for that, we use hyperparameter optimization techniques. Here I'm using the base, again, grid search CV only. I'm giving a range of K values, which will be experimented starting with 3. All the odd numbers I'm taking, because the step size I'm taking it as 2. So from 3 till 49, all the odd numbers will be treated as K. So I'm building a KNN model with these parameters that I'm defining here. And I'm doing a cross validation with K as 5. This is our grid search CV model. I'm defining it and I'm training the data set. Done. And this is my best parameter, 11. K equal to 11 is giving us the very good accuracy, 95.6%. I'm using this for prediction. This is my prediction data. And I'm also doing it on test data set to get the test predictions. This is my result, confusion matrix, and all those things we are doing here. Okay, this is for visualization purpose. Okay. All right, now we've identified the best model, so we are deciding to save it. I saved it. All these files that we have saved is going and sitting in this particular folder. C drive users process, right? So KNN, preprocessed 1, preprocessed 2. So these 3 files are what we have saved. Okay. Now comes the monitoring. So forget about model monitoring. We'll first focus on data monitoring. You will have to get evidently installed. You have to say pip install evidently, and you'll get this library. Right. And as I mentioned, right, evidently is a open source. Yeah, this is the website, evidentlyai.com. And you have GitHub repositories where all the publicly available code is available. You can access those codes directly. You can also have right, individual modules like this. So how are your models doing in production? You want to monitor them, right? So you can basically look into your model performance using this concept. Data drift. This is what we are focusing on, right? So we'll be discussing about this. And within the data, we also have target, your output variable, right? So that is also probably changing over time. So we'll also have to understand how it is changing. With respect to the data integrity has to be checked, the quality has to be checked, right? So those things will be verified using this particular module. All the codes are readily available. You can just click on this, get started, and you will be taken to that particular tutorial where you have code readily available, right? You also have video. This is the code you want to experiment with. Let me show you how this works. I'm using test suite, evidently.test suite. First, I'll have to import, and this is the version. You can see 0.3.0. That's fairly new, right? Not even one, right? Version is not even one. So I'm basically trying to use the evidently tests and metrics functionalities. I'm importing all the available functions here. And I'm also using the test suite. The report basically allows us to generate a report with respect to the calculations that it is doing in the backend. Right? And I also will talk about the target drift as well. Now, I'm trying to collect the information into a single data set. So if you talk about X-test and X-train, this is basically your input features, right? The cleaned input features. But what is the output for this data set? Right? So I'm adding that data back. This is my target historical data. So my X-train is 32 columns, which contains input and output now. And I'm also recording the predicted values. I'm calling it as prediction. X underscore train now is 33 columns. So you have target value and you have predicted value, along with all the inputs. So complete data set, but only the training data set. Likewise, I'm creating my test data set also. So 33 columns. Next, I'm calling my target as target only. I'm loading that as target. This is a function called column mapping. We'll basically have to map all the columns, right? What is target, what is predicted value, what is input, and all that. So from that perspective, I'm defining the target and predictions. And also, you have to define that you have numeric columns and categorical columns in your data set. So this column mapping function will try and map the respective functionalities that are being used in Evidently to the respective columns or respective fields. So if your data is numeric, you cannot perform certain tests. If your data is categorical, you cannot perform certain tests, right? So it is automatically defined. All you have to use this column mapping and define these things, right? What is your target? What is your prediction value? And then input values. Then this test suite, as I said, contains a lot of tests that are readily available in your evidently.ai. There are data drift related tests, there are data quality, your output related tests, right? All these are predefined, like how many number of columns are there, how many number of rows are there, missing values in each column, right? Number and then share, proportion basically. How many columns with those missing values, how many rows with those missing values. So on and so forth, you can see a lot of these integrating based tests are being performed. So I'm basically calling all these tests. Test suite is equals to, these are all the tests that I want to perform, right? So this is your data set integrity test. I'm defining this using the test suite. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tests are being performed. All you have to do is use this function and then say run. But when you're running this, you have to basically pass what is your historical data, that is referenced data, and what is your current data or your new data that which is being used for doing the predictions, or you're basically working on this new data, right? So you have to say train is your reference data, test is your current data. If you have multiple versions of your data, old version becomes reference data, new version, new data that you're getting now is becoming current data. That's all. These two have to be passed. I'll run this. So this is getting me some results. Okay, it is generating some results here. If you say, it gives you an output. This data can be saved in different formats. For us to understand, I'm generating a HTML file. I'm calling that HTML file with the same name. Data integrity dataset test, right? I'll say save underscore HTML. That is the function. I'll run this. And this is going to generate a file, the HTML file. And that file is getting stored in our current working directory. You can see that path here also. So I'll go to this. Yeah, you can see that file here, data integrity test. So how many tests we were running? 15 tests, right? So it's basically showing those 15 tests. 14 tests have been successfully run. 1 test has failed. This is the test which has failed. The number of rows, obviously, there will be difference, right? So it is basically showing that it is failed. Number of columns is 33. These are the columns. Reference data type, current data type. You can basically see both of them are getting compared. Number of missing values, there is 0%. There was no missing data because we have done imputation, right? So if you're not doing imputation before data pre-processing, if you compare, then you would get the differences. Right? Similarly, the percentage, the share, both are similar. One is number, the other one is percentage. Okay. Likewise, we have 15 different tests which are performed and the report is given. You can also perform column-wise specific tests and generate an HTML report. I'm executing all of this at one go. And you get a new report. This is column specific report. We are doing 5 tests on this particular column, right? You can see the code. We are basically doing these 5 tests on this column, 6 column. All right. Then the data quality issues, conflict with target predictions, correlated columns, right? All these are your quality issues. So here we get another report. Change in the correlation. The number of correlation violations is 33. These are the details. Of course, the correlation varies between the data points because of the size of the data sets that are there. Right? These are highly correlated columns. It basically says 90 highest correlation, right? Maximum correlation is this much, 0.998. It's almost equal to 1. Right? You can see the color and probably you can understand what are those high number values. So radius worst and area worst is something that has similar correlation. Now, this is very interesting, data drift table. This is what you need to basically try and look at. I'm executing this. We are generating a report, and this is the function. These are the specific tests that are being performed, carbonograph division test, and this is PSI test, which is basically done for categorical data points. And once this is done, we are passing defined, we are passing the data set and we are generating. So we get data drift. So this is our target. It's benign and malignant, right? For reference data and current data, we are doing the checks, right? And this is your categorical type. So the statistical test that we have performed is PSI. All right. So this is basically how we look into the other tests. All right. This is helping us to understand the data drift score. Okay, it also quantifies the drift, and drift is detected for these many data points. So whenever you get new version of data, you run these codes so that you will be able to understand that the distribution has changed. And you would probably based on your knowledge, based on the domain knowledge that you possess, and based on the experiments that you're performing, you can define a threshold saying that if the overall drift is beyond 15%, then I will do the retraining of the data set. So you'll have to trigger the training job. Continuous training is triggered that way. So you'll have to write a scheduler, use a scheduler, and using this result, you'll basically come up with the retraining function. So you'll basically call that function. Right? So these are all the reports that you can see. In fact, you can also change the colors. All right. Now, these are the different types of reports that we can see. So you can see, okay, let me just run this. So it is giving me a data stability report. Okay, the similar tests are performed here also. I'm giving different name there, right? So it basically looks at out of range, missing values, mean, right? All these calculations are performed for all the 33 columns. Okay, individually it is doing for every column. Now the same result can be saved in a JSON format. You can save that file. I mean, this entire result, you can save that into a JSON file. Or you can also get this into a dictionary like this. Right? So you can basically get a dictionary here. So key and value pair is what you're getting. This is the test. This is whether passed or failed. All right. So we can use this information for generating your UI. You can also create dashboards, integrate your UI with that dashboard. So this is how we perform model monitoring and model maintenance. Of course, there's some additional work that needs to be done. You can refer to this publicly available documentation on the website, and you can take these codes. So here you can see this is basically talking about data drift, which includes input and output, target drift as well. Right? You also have a sample data set being used. You can try working with the sample data set and then customize the code for your requirements. You can also, as I said, right, customize the result also. You can show both the results in the same page rather than right in this format. You might want to show more details with respect to your statistics rather than UI. You can change that. This basically is the code which is right used to alter your screen size and all that. All right. So basically what we are trying to use or perform or do is this one. Once the model is identified, once it is deployed, the expectation is that the model should perform consistently. Perform consistently. For that, the major ingredient that is required is the data, and this data should be consistent. When I say consistent, its distribution should be constant. Previous data and current data, it has to be similar. The missing values components, right? The outliers, all these aspects have to be similar. For that, we are using reports gathered as part of the preliminary analysis, and then we compare those reports to capture the drift, the change that is introduced into your data. If you are able to capture this, then you'll also be able to understand the model drift. Of course, for model drift, again, we have different other softwares also that we can use, including Evidently. We can also use Evidently also. Right? But yeah, we do have several other tools that can be also perfectly used for data drift and model drift All right. So this is basically an introductory class, more like an overview of what you can do after your model is developed. And as I said, right, there are hundreds of different tools like this which can be experimented. Start with Evidently, because it is very simple, very easy. Simple pip install command will give you the software, and readily available code is there. So you can start Evidently very, very easy. All right. So hope you'll start using it, and we will connect again in these kind of sessions. We'll come up with something new tool to be discussed. Until then, take care, friends, and hope you have enjoyed the session. Thank you so much. Good night.